Okay, so let's try a couple examples about bootstrapping. Well, first off, suppose the original sample were the numbers 17, 10, 15, 21, 13, 18. So, out of the 5 choices you see on the screen, which of the following is a possible bootstrap sample from the original sample? Well, for the part A, 10, 12, 17, 18, 20, 21, that is not going to be a bootstrap sample. And the main reason is because, well, the number 12 is not in the original sample. And for that matter, the number 20 as well. For part B is not a sample either. I mean, 10, 15, and 17 are all part of the original sample. But you want to have a sample size of 6. So we need to continue on. This would be a bootstrap sample if we continued on for 3 more picks. C, 10, 13, 15, 17, 18, 21 are all in the original sample. That is a bootstrap sample, or that at least potentially can be. Part D, 18, 13, 21, 17, 15, 13, and 10 are all in the original sample, but in this case, my sample size is too large. I need to get rid of that last one, or get rid of one of them. And then part E, 13, 10, 21, 10, 18, 17. Those are all in the original sample. This would be a possible bootstrap sample. Alright, so let's try to create a confidence interval using bootstrapping. Suppose we had a random sample of 1,000 people and 35 agree with a certain statement. So 35 out of 100 would be my point estimate. So, and now we want to give a 95% confidence interval for that proportion. So what we can do is we go to Stat Key, and I'll choose confidence interval for a single proportion. And see, I want to edit, and basically I'll say 35 out of 100. So the count is 35 successes out of a sample size of 100. And now I can generate 1,000 samples. I can do 2,000. Let's go wild, make it 3,000. Anyway, you can generate thousands and thousands of samples. One way to get to 95% confidence interval is to click on this two-tail and make sure the middle says 95% or 0.95. And you can see right here in the lower left, 0.260, that's the lower bound of the interval. 0.450 is the upper bound. So my 95% confidence interval is between 26% and 45%. Now, that's one way you can do the confidence interval. A second way is to make note of the standard error up here in the upper right, 0.048, along with our point estimate of 0.35 right here. And then with a calculator, I would go 0.35 plus 2 times the standard error 0.048 and 0.35 minus 2 times 0.048. If you want, you can use 1.96 instead of 2, which would be the more accurate for a normal distribution. It's just that bootstrapping is not quite as accurate. You can't really expect quite that much accuracy, so 2 is more than sufficient. But the results, 25% to 45%, are pretty much the same results we got with the other method. Here's another one I did earlier. I generated 1,000 samples, and you can see right here on the lower left, that's the lower bound if I'm going that route to 44%. About the same thing I got with my latest attempt. But in this case, we're 95% confident that between 25% and 44% of the people agree with the statement. A second method is to make use of the standard error, and then we figure out the point estimate was 35 out of 100 or 0.35. Standard error 0.047. Then 95% confidence interval would be 0.35 plus or minus that 2 times that 0.047. and we would get from 0.256 to 0.444. So nearly the same numbers I had before. So we are now, again, 95% confident between 26% and 44% of the people agree with the statement. All right, let's try one more. How many ants will climb on a piece of peanut butter sandwich left on the ground near an ant hill? That's one of the important questions to ask these days. To study this, a student in Australia left a piece of sandwich for several minutes, then covered it with a jar and counted the number of ants. He did this 8 times, and you see the results below here, where the number of ants on a sandwich ranged from 43, 59, 22, 25, 36, 47, 19, and 21. All right, so let's figure out the mean and standard deviation and go from there. And you can actually do that with the Bootstrap with StatKey. In this case, let's just go back to, I want to figure out the average, so I'll choose confidence interval single mean. And then if I click on this edit data button at the top, I'm able to change it to the numbers for my sample, which were these 8 numbers. And you can see in the upper right here, the mean is 34 right there. Standard deviation 14.629. So the mean is 34, standard deviation 14.629. Now, let's create a Bootstrap sample. You can see the one on the screen, but I'll do one right now. There's 1,000, 2,000, 3,000, 4,000. Okay, and there's 5,000 samples now. And again, one way you can find a 95% Bootstrap confidence interval is to generate, 5,000 bunch of samples. Doesn't have to be 5,000, but you do it many, many times. And then one way is to click on to tail there and make sure the middle is 95%. Now, if you want to do a different confidence level, you can click on that and choose, like, say, you want to do a 90% confidence interval. Oops, and that's now it's 90%. Let's go back to 95. Anyway, in this case, we're going from 24.9 ants to 43.6 ants. For the one you see on the screen, 24.9 to 43.6, essentially the same numbers. So my 95% confidence interval is that we are 95% confident that the average number of ants that will climb on a peanut butter sandwich is between 24.9 and 43.6 ants. Now you know.